In this lesson, we will talk about the end behavior of a polynomial function. And what that means is what will the ends of our function look like when we graph it. So that all depends on two things, which is the leading coefficient, whether that is positive or negative, and whether the degree is even or odd. So first let's think about this, which is our normal even function with that positive leading coefficient. If I had a squared value, my graph would be a parabola pointing up. If I had something to the fourth, that's like this. It's like a W. If I had something to the sixth, it might look like this. Now, what do I notice about all of these things? That on the left side, it goes on forever to positive infinity, and on the right side, it goes on forever to positive infinity, which means both of those are going in the same direction. Now, if it's still even, but now a is negative, this one will flip upside down, and this one will flip upside down, and this one will flip upside down. So I know that they're still going to go in the same direction, but they're going to be going in the negative direction instead. So that means every time it's even, they're the same direction, but if it's negative, we flip them upside down. Now let's look at the odd functions. If I have a linear function, that's the degree of 1. I know my graph looks like that. If I have a cubic function, my graph looks something like that. Notice it's starting on the bottom left and going up to the top right, same as my linear. If I had a quintic function to the 5th power, again, it would start low and end up looking something like that. So it starts bottom left, goes up to the top right. That's what I know about an odd function with a positive. And just like we did here, I know if the a value is negative, now my linear function is pointing down from left to right. Now my cubic function is pointing down from left to right, etc. So it's still going to end in opposite directions of each other, but it changes which part is positive infinity and which part is negative. So let's look at these without even having to graph them and have an idea of what the general shape of the graph is going to look like. This is a quintic function. It's to the 5th power. 5th power, that's odd. That means opposite directions. And notice it's a positive in front because there's nothing there, which means it's positive 1. So I know that a quintic is going to look something like this. Where those points are, honestly, it doesn't really matter. We're just looking at the end behavior. So on the left side, it's going to go down to negative infinity, and on the right side, it's going to go up to positive infinity. Now, why are we spending time on this? Because we're going to end up graphing these functions, and it's important to know that we're graphing it correctly. Now let's look at this one. I don't really want to multiply all of this out because I'm very, very lazy. What I do need to know is what is the degree. So I have 3, 4 x's. X to the 4th would be my highest degree. So this is an even. Remember what evens did? They either ended up like this, or they went down like this. Which one am I dealing with? Well, I know when I multiply all of this out, that's going to be negative. So that means it's going to start to negative infinity, it's going to end to negative infinity. If you don't believe me, feel free to multiply all of this out, but your first term should end up being negative 2x to the 4th, and that's how I know it's going to be an upside down w. Here's one for you to try on your own. So try this question and then press play to check your work. Again, this one's much nicer than the last one we did, but it is an even function, and even functions are going to look like this, something like this, or they're going to go down. This is the 4th one. And I know because it's negative, it's going to end up looking like this. So what's the end behavior? It begins down to negative infinity, it ends down to negative infinity. So that's the two end behaviors that I'm concerned about.